So I want to welcome Krizia Fernando, who is a product design lead at Evernorth. She's worked in education, nonprofits, and in the IoT space, building toolkits and systems that help product teams work more inclusively. As co-founder of the Femcubator, a nonprofit supporting BIPOC women in tech, Krizia designs open source products and teaches workshops on emerging technologies. In 2024, she was recognized as an Aspen Ideas Fellow for her work on the Fem Incubator and OpenCivic.tech. When she's not designing, you'll find her taking film photos while traveling. And I'd also like to welcome Kris Rubiano, who is a project manager specializing in civic technology and machine learning. From design to data, they design the evolution of community initiatives to ensure technology remains inclusive rather than a barrier. This multidisciplinary approach is motivated by a desire to solve problems from every angle, balancing UX-driven empathy with the technical rigor of data analysis. And today, they're going to talk to us about Smol Gardens, sort of how I see it, accountable AI for civic tech. So if everybody can give them a round of applause, that would be great. And with that, I'm going to turn it over to you so you can start sharing your screen.
Thank you, everyone, for the invite tonight. Welcome to the Smol Gardens project. I'm Krizia, and I'm here with Kris from Femcubator. And thanks for that super cool introduction. But today we were able to join you all because a special shout out to Gabe for inviting us tonight. We truly wanted to make it happen, and virtually happy to share. So to start, we're civic technologists. Like me and Kris, I would say that we identify as civic technologists. In the last 2 years, we've been also spearheading initiatives through Femcubator and the Open Civic Tech Project. And this year, we happen to have conducted 2 workshops. Tonight, you'll hear about Smol Gardens, and it's about accountable AI and civic tech. It's a topic that we shared at a makeshift conference in New York during NYC Design Week. And yeah, without further ado, I'm gonna hop in. I just want to make sure you're seeing everything correctly. Okay, so talking about this, can we actually build responsibly in the age of AI, right? Today, I think we're gonna have to dig deeper a little bit. We're gonna explore this question together. There's a few accountability issues. What you can see on here tonight. Okay, so my question was, can we build responsibly in the age of AI? And I was going to talk about this feed. These were screenshots from March of this year. And if y'all are watching the news, there's more about vibe coding presenting itself as safety issues. So Anthropic warns of new vibe hacking attacks that use Claude AI, right? So anyone here who vibe codes, you gotta definitely keep track of that technology using Claude or any other models. And then here it talks about unauthorized use of writers' work, where Grammarly is using identities of writers without their permission. And someone wrote about their experience there. And then the last piece was about vibe design, which is Google is saying that vibe design is going to be a job killer for many developers. So these types of headlines, some of them are from partial news outlets that are more neutral. But if Google is the one that's saying that, vibe designing is better for us in the future so that there's no need for designers, I feel like there's, if you're a questioning person, these are things to think about, right? So with Smol Gardens, I just wanted to kind of run through how our talk today is going to go. For a half hour, we're going to just walk you through what we found in the 2 workshops that we posted, and I'm going to share kind of the workshop results. I'm going to share about Seed Score Impact Assessment Tool and demo it a little bit, and we're going to get into small language models, where Kris is going to talk more about that in demo. Then we'll have a little bit of Q&A before the workshop activity where we're vibe coding, if y'all are going to want to join that. So how can I share my personal experience here? Like I mentioned, I'm a civic technologist. I've been a civic technologist even before I joined my job in technology because I just love working with the community. So last year through the Open Civic Tech Initiative, I tried starting this equitable mapping project and I did vibe code myself. I'm not a developer by trade, and this is something that was really, it blew me away. I was like, if I could build and vibe code using libraries through Bolt or Lovable or Claude, I can do whatever and help my community. So it kind of like gave me such, it empowered me as a designer. So what can we take from this innovation and but think through and what are the harms? And I looked everywhere and it was not easy for me to sift through that information. So the key questions I had after building this, data visualization and mapping is a specialized field in itself. So who are the key players? Who are the experts? Can I reach out to them? So in the end, we reached out to Data Women NYC, and we got three mentors from that work, and they were able to help us host the hackathon. We kind of like abandoned the vibe coding idea and just worked with the mentors and hosted one with the students. And then we also asked like, when we vibe code a project like this, what's going to happen to it? It's the service, right? If you think about it, you ask people, think about Craigslist for equitable mapping. You want them to submit a request for like what type of data is, and someone's like, I want to know more about farmers market in New York City. Who's gonna do that? Like, who are we vibe coding that, or are we gonna deploy, actual experts to help with the maintenance? And how do we ensure data privacy and accessibility is also thought of from the beginning? So again, vibe coding is great for greenfield and prototyping, but then we have to think about the surrounding issues as we build services and products, right? So again, putting that question, can we build responsibly in the age of AI? What are the alternatives that don't create redundant, unmaintainable, or harmful solutions? And as AI becomes more widely adopted, what are the trade-offs? What are the guardrails to help teams build responsibly? And in civic tech, what do builders, designers, and researchers think and feel about using AI tools in their processes? To do that, we actually were able to pitch this idea through Beta NYC's Untold Data Conference in March. We were able to talk to 15 civic techies to share their thoughts on AI-enabled web development. These were the discussion points, right? Compliance and accessibility gaps, maintenance and scalability issues. A lot of the data scientists were talking about convergence toward average, so that every time that's also why we get AI slop, right? Like when you try to build something for web coding, you get very meh results. They're not really wonderful and they're all looking the same because it's predictive data, right? Skill and community erosion, environmental and health consequences, which is kind of big right now about tokens and inference, and then redundant solutions, right? Like if I have to keep building maps, what about open street maps, right? Like there are other ways to be rebuilding using existing maps. Ownership, access, and accountability, black box training data, bias, and marginalized voices. I didn't want to speed through this, but throughout the whole experience in the vibe coding today, I think we're going to touch on those points and talk about those data index that we pulled from that workshop. And I'll show you seeds in a little bit. So on top of that workshop that we did, we also are taking into consideration existing responsible computing toolkits. So Mozilla Foundation actually built this responsible computing challenge that encourages undergrads, colleges, students to build toolkits. So look into that. They talk about, tech for society type of principles. So think about technology as situated, stakeholder impact analysis, thinking about power structures, and multidisciplinary evaluation using qualitative tools. One of the things that I really like was this toolkit that UC Berkeley created, which, the toolkit is almost like you have 15 concepts and what are the questions surrounding that. So a lot of the work that we're trying to do is inspired by these toolkits. So what is Smol Gardens? Think of it as a study, a tool, and a guide. So phase one, we're thinking to just continue doing these workshops to invite builders to join the workshop and kind of just give us their feedback. How are they feeling about building right now? What are their thoughts around like this tooling, this impact assessment toolkit? Phase two, we're thinking about refining the impact assessment toolkit that has 15 data index inspired questions And then we want to build a builder's guide alongside the civic checklists that we meet along the way. So talking about seed score is our second phase, right? Remember, impact assessment toolkit. Um, just talk about this really quickly. This is, a dashboard that kind of just exposes and visualizes your usage as a builder. So there are three core pillars in the impact assessment tool: human systems and environmental impact of AI-enabled development. And it really focuses on like vibe coding as an activity. For each pillar, we developed 15 sub-questions to invite builders to self-audit their build process. And then the dashboard report is just a way for them to assess their impact. So in the future, not necessarily tonight, but you will see more about these tags and it's hard to see clearly right now, but like human impact is like a question around the participants gain capability, ownership, and transferable knowledge through this process. For systemic, did we build something communities can own, maintain, and trust without depending on us as original builders? And then for environment, did we take responsibility for environmental costs of the AI we used? And then here's the seeds for a demo. I'm gonna just try to show you. It's not yet ready, but you could take a peek at it. So essentially, you talk about the project that you're building, description, what model did you use, team size, and all that. So this is kind of like all the project information. And then you'll go through the 15 questions. And it's almost like a little questionnaire right now. So as soon as this kind of like gets available and ready to use, I will definitely send you the information, but I'm going to fast forward this to the dashboard. And it's just almost like a scorecard that gives the builder an opportunity to just keep track of, kind of like these are principles that we can help improve and build, kind of just refine in the future. But hopefully, like this is something that builders can use to just keep track of accountable AI principles. So yeah, that's essentially the intro for Smol Gardens, and I'm happy to just turn this over to Kris. But Kris, I could drive
Yeah, can you operate
this
the
for
slides
you,
for
and
me? Thanks.
yeah, I'll do that, and I'll just mute myself.
Yeah, and then
Thank
I'll be
you.
switching over. Great. Okay, hey everyone, I'm Kris Rubiano. So I'll just be introducing small language models. So basically, small language models are defined by how they compare to large language models. And I'm going to go briefly over what their advantages are over LLMs, and go, just talk about some of their use cases that are in effect today, and of course, their environmental impact. Next slide, please. Yeah. So SLMs. So I'm going to talk about three main things. First is their operational efficiency. Due to their size being small, of course, they are built with fewer parameters. And I'll be going more in depth on those as soon as I consider that to be one of the biggest factors here. And a lot of these small language models can be deployed on local hardware, such as a laptop or a mobile device without connecting to a large data center. There's also they're domain specific. And what that means is that while LLMs are made to understand and generate a multitude of different features, such as writing, translating, and producing code, as we've been talking about, SLMs are made for highly defined tasks. So you could, in theory, just make an SLM that is only for code, and it would not understand translating material because you've built it only for producing code. So that's a highly defined task, and this can be used for chatbots built for specific subjects or only on text generated from documents you provided it. And last, because of this, they're cost effective in scaling. So because they are small, you don't need as much processing power, and you don't necessarily need to be online to connect to a cloud server and access that required information. Next slide, please. Yeah, so here's some use cases that we may have experience with. First is texting smart applies. You might have seen this in emails or when you send out text messages. If you type something in, we'll just generate, maybe you would like to respond with this. So that's actually using SLM in the background. And also semantic photo searches. If you use this for your phone and you try to look for a photo through filtering, that is also operating on SLMs in the background. So it's a very specific feature. I believe you can use these features also offline. Well, specifically the photo search offline. So it is running off your entire device and it's only reading your own photos. Next slide, please. Yeah, so here we go about parameters. These are the big things. I gave this talk initially to people who are not very familiar with the technology behind it, but I'll try to keep it more simplified here. If you are familiar with tech, that's awesome. You will probably understand what parameters are. But basically, Parameters are the internal settings and the controls for all language models, large and small. Because large language models need a lot of parameters to understand its weights and biases from its enormous amount of information and data, it requires a lot of these parameters running in the background. Um, because small language models are domain specific, as I mentioned earlier, they do need less information and data in comparison. So its internal workings are less complex, and therefore you can use less processing power and energy to run them. The main items in parameters are basically weights and biases. And the best way I would describe this is how does the model understand the information? For example, it's how the model focuses on specific details versus the broader context. And also the connection strength is the model seeing the correlation between inputs. So if I'm telling the language model that I'm talking about coding and then I bring up Python, it's knowing I'm talking about the language Python and not the snake. So that's how weights work. And then biases are the model's baseline worldview on how it makes predictions. So in regards to how it handles ambiguous inputs, it will try to understand how it should act when the input isn't clear. If I mentioned, let's say, apple in context, it might ask if I'm talking about the fruit or am I talking about the company or something else. And if the model is like biased towards knowing about coding or computers, it will probably think I'm talking about Apple the company. Or if it's for some reason more trained about food, it'll be like, oh, you're talking about the fruit. So large language models usually have 1 trillion to 100 billion parameters in comparison to small language models, which usually have, let's say, a few billion to maybe 10 billion. So some people may have no idea how big trillions are in comparisons to billions. So here's a chart on the next slide. So yeah, large language models are in blue. These are all hitting up to 1 trillion and 100 billions, and all the small language models are noted in orange. I actually cropped off ChatGPT 5, which I think has 5 trillion and would definitely exceed what's going on in this chart here. At that point, you would not see any of these orange bars. So that's how many parameters large language models are operating. I did highlight small LM2 on the bottom here in red. I'm going to hopefully show a demo of that real soon if my screen share decides to cooperate later on, but I'll be running a little small language model myself. Next slide, please. Yes, of course, the environmental impact. So those trillions of parameters running are amongst the reasons why those data centers and energy consumption is happening for those large language models. So again, from their size and focus on specific tasks, there is a cost-saving aspect to small language models, and fine-tuning these models can offer a reasonable accuracy for their purpose with the smaller digital footprint. Of course, there will be a question if we have too many small language models, will it eventually equal the same as one large language model? But it seems to be a useful alternative in comparison moving forward. So next slide. Yeah, so where did the name Smol Gardens come from? It comes from a small LM demo. So Hugging Face is just basically a collaborative platform for machine learning tools, and Smol LM is their model system for small language models. It's one of them. I'm going to try to run one, and we'll try to attempt to vibe code with it. Not going well, but we'll see how this plays out. Let's see if I can get the screen share working appropriately. So this is basically run on Python. This is just Hugging Face's small language to instruct. This is probably their biggest, smallest language model. It's all running locally on my computer. But in terms of trying to get a bit of vibe code, I gave the simple directions. You are a minimalist web designer who writes single HTML files. You will be asked to generate HTML, simple CSS, and basic JavaScript. Always match the HTML IDs and HTML classes with the DOM selectors used in JavaScript. And output only valid HTML code, no conversation, no mark blocks, etc. Because I've been trying to tune this model to not take up too much processing power, but still get me hopefully working code. I would say I'm not the most attuned person to making small language models yet, but this has been an attempt, and we're going to see how this plays out. So I'm going to go pull up the command line here. I'm just trying to make this a little bigger for everyone to see. So, oops, put that environmental Python demo.py. We'll see how this lies because I usually run it not on a Zoom call. That's also using up my processing power. I think should be going on from here. Okay, prompt. So I will say, create a web page featuring a countdown clock using JavaScript. The target date is, and hopefully I did my research correctly, October 26, 2064, the Toronto municipal election. If I got that wrong, I'll fix it next time. But let's just go with this date. I'll say the clock should display days, hours, minutes, and seconds. And let's try some CSS in here. Background, I'll say the page background is white and the text is red. Let's see how this runs. Okay, that's good so far. It normally gets the HTML pretty good. It's got the CSS there. CSS looks okay. The JavaScript is where things get a little shaky, and I don't know JavaScript right away to tell you if it kind of exploded a bit, but it seems to be doing a little okay. Oh, that doesn't look good. Okay. This will hopefully finish though, but it is showing a good example that you can run the model to try to attempt to code. Always hangs up on the JavaScript, but I'll try to run it before and let's see how it goes. This shouldn't take too long. It actually finishes up after I guess these constants out. But otherwise, I hope everyone's preparing questions. Ooh, I hope it's not hanging because I'm on Zoom. Oh no, okay, it's going there. It's like cheering my little model on. Let's go, model, you can do it.
Turn off your camera.
Everybody start pedaling.
Yeah. I'll give it like maybe another 30 seconds and then I'll consider it hung or something because yeah, I mean, again, this is all running locally on my own computer. So I'm sure the fact that I am on Zoom and it's using up that processing power is why it's lagging. Oh, look at that, it's going.
I'm gonna drink water for you.
Yeah. Oh, there we go. Look, it's gonna wrap up after this, hopefully. Oh, cool down. Oh, it finished. Okay, great. Now the question is, does this actually run? That's a new thing. So I'm gonna copy all this, try to put it into a new file here. Let's see. Ooh, I gotta close this. I'm not used to Zoom having my window space here. I'm gonna save that. I'm gonna save this as demo.html. Let's see if this will also share or it will not work anymore. Where is it? Ah, too many windows. Oh no, it's not working. You can tell by my preview it's not working. Oh, it did something. I don't know if that's accurate, but it did something. I don't know if this was even sharing correctly, but I mean, there you go. So that was my demo for small language models. Thank you. All right, Kris, you can back to the slides now. Thank you.
Oh yeah, you're right. So let me share.
Refresh it, it kind of works. That's why we're vibe coding. That's why we have to fix it afterwards.
Yeah, and I think I wasn't sure Gabe or in-person team. Did we want to do Q&A before the workshop or do we have time?
Oh, well, we're probably going to do the Q&A now, but we do have a bit of time to take maybe two questions, one online and one in person.
Hi, really nice talk. I think the environmental impact is probably the most, it's really good to hear about. I do wonder though, I think if you train on a specific kind of data or data about a specific topic, would you lose some of the emergent abilities that an LLM has from connecting disparate kinds of topics or disparate kinds of data from different topics. Do you see this as like a complete replacement for LLMs, or like something that could be like fine-tuned from LLM, or like treated for specific use cases itself?
Yeah, I could take this one. Yeah, so I feel like if you do fine tune for very specific cases, like if you in theory train your model entirely on, I would say, I'm trying to think of like in a medical system. Like if you would just say, oh, I'm going to teach my entire system about heart attacks, about the heart, and then you would just ask in sort of like a Q&A system if you use your small language model as that, then we'll only understand about that material. And that means like you don't need to waste all the expensive energy about like, well, you want to know about the brain as well. I mean, those could be connected in theory. But if you really want to have it very specific on the SLM, I think this would be a great use for it. Also because, like I mentioned, it can be run locally if you're concerned about security concerns. If it runs entirely locally on a certain machine, then maybe there's no concern about your data getting leaked out if you have medical records set up in there about heart conditions. So I think this would be a great alternative instead of, again, having a large language model where it has information from possibly way too many things at once that you don't need.